So on the bench here, we have a Siemens FD800 8-inch floppy disk drive. And just to give you an idea of the size of this, since it doesn't show up well on camera, there is a floppy, 8-inch floppy, and there's a 5 1/4 inch for comparison. So you're probably all familiar with 5 1/4 inch. So this is a very old school 8-inch floppy drive. I'm having issues with the power supply, or really with the drive affecting the power supply. When I plug the power supply in to the drive, the voltage rail collapses. There's basically what seems to be a short or a near short on the power supply. Most suspect is a bad tantalum capacitor. So hopefully that's showing up in camera. Let's take a look and just make sure that you can read the meter, and you can. So let's look at the incoming power connections. So we've got one side comes in over here, and we're seeing about 32 ohms, which is reasonable. On the other side over here, we're seeing 2.3 ohms, which seems really low. It's not a direct short, but when I hook the power supply up to the unit, the voltage on the power supply appear to collapse. I've got a functional drive I've been testing with that the video hasn't made it out yet. Probably will before this video, we'll see. And when I hook this drive up, the working drive fails to work as well. I haven't actually measured the voltages with it hooked up to see, but I'm guessing, it's 2.3 ohms. I think this is the 24 volt side. So that's going to draw 2 amps right there, which is much more really than this should be, or 12 amps. Take that back. 2 ohms at 24 volts would be 12 amps, which is just ridiculous. So there's some tantalum capacitors on here that are suspect based on part number C46 and C43 are tantalum. So I believe these two large guys here are tantalums, and my guess is one of them is the issue. And so we're just going to do some quick playing here and see if we can isolate these and go from there. Let me see if I can determine which one is which. So that's the positive input. Does it go to either one of these? Nope. Well, it seems to probably connect over to this guy. Now that doesn't make sense. He's connected there. Seeing that 2.2 ohms again, I'm not sure. So we're going to have to pull these out and take a look. And I think to do this, I'm just going to try to heat one leg, bend the device up out, and we'll see what we get. There's also this C41 here that again is a different case design than I'm used to, but I know there's tantalums on the board based on what I saw in the schematic. I don't see as many tantalums on here as the schematic seemed to imply. There's two up here that are obviously tantalums. These are ceramic discs. There's a tantalum sitting there. As much as I want to think these are electrolytic, I'm guessing they're not. So let's see if we can lift legs on one of these. Oh, the bench is a mess. The bench is always a mess. Where's the this guy right here? Get the tip cleaned up. I want to add a little bit of fresh solder here. And hopefully I can just heat and lift and get this leg to lift up out. Just like that. Let's see if what appears to be a short goes away. Nope, still 2-point-something ohms. So I'm guessing this tantalum isn't bad, or this cap. Let's go over to capacitance. Just see what we measure on it. measures 20.4 microfarads, and it's supposed to be 22 microfarads, so interesting. So that potentially isn't the issue. So we'll just keep kind of working along here. Some brush solder to him. See if I can get him to lift up out of there. Oops, it would help if I was in ohms here. Mode. Now that's still going to be about 2 ohms. Let's see about lifting that guy up. I'm guessing that's a capacitor. Let me try the other glasses here, get a better look at the part. Yeah, this black guy here is a capacitor as well. Get some solder on there and see if I can get him to lift up out. Well, that's up to 5 ohms. No, 5 kilo ohms. So what does this guy measure on his own? There's our 2 ohm problem right there. So this capacitor is definitely dead, and I'll bet it's a 10 ohm. It's 6. I have a hard time reading it. 6 something 8 microfarads. Let's go ahead and pull the other leg up out, but that is most likely the reason why the power rail collapsed with the drive hooked up, is that capacitor right there. So let me get him off the board. C41, maybe 688 microfarads. Is that really a, it's definitely microfarad. 23rd week of 79. Kemet. Well, let's try capacitance here just out of curiosity. Let's see what we got. Yeah, it's not measuring it as capacitor at all. It's definitely a shorted device. You know, 10 ohms are never your friend. That's definitely the source of our 2.3 ohms. All these tantalums should be replaced. They will fail at some point, but I'm going to go ahead and just remount these two because I can. Hopefully I can do this from the top side of the board, getting enough draw from the vac tool to open the hole up all the way through. It's appearing not. Yeah, see, these two didn't clear. We'll try one more time from the top before we flip the board over. No, I'm going to have to actually remove the board. I was hoping to not have to, but it's obvious I'm going to have to. This guy is glued on, but the glue is really old. So this is one of two drives that I bought that were supposedly new old stock. But I'm not convinced they were actually new old stock. I think they were removed from service and put back in the original packaging the replacement drive was in. At least that's my best guess. Let me see if I've got a Torx bit big enough with me here. Release those screws. That looks way too bloody small. Nope, that looks like the one. So given that that bad tantalum is right down by the tip 35, they're tip 35 or tip 31 transistors down there, I'm guessing that's voltage regulation potentially, or much probably actually the stepper motor drivers now that I'm looking at it. So P5, P6, these are all labeled. That card should lift up out of there. Take a look at where we're working. A little bit of a tight spot there to get into. I don't want to melt the nylon. For the power connector there, let's see if I can get the tip in here without touching it. It kind of cleared the hole. Not as much as I would have liked. And we'll try it again. That's better. And we have another hole. Where is that? Oh, that one's actually already open. And so it's really right there. Boy, it's up right up against the nylon again. It's obvious why that wouldn't unsolder from the other side. There's a huge pore on this side of it. We'll get some fresh solder in there. Let's see if we can carefully get in here, get it to meld. That cleared it. We've got the guy we removed. The other side of him seems to go to right there. I think with that, we can get the originals back in place. Maybe if I put on glasses I can actually see with. You're really going to be stubborn, aren't you? There we went. And you. I can see lead poking through for both, so we can get those back in place. I don't want to melt the nylon on that incoming power connector. There was a tantalum there, which I need to try to get both holes open on. Have to look in the parts list. Odds are, at this point, I could at least power this up and see if it worked without that cap, although that's probably not the smartest move. Gonna have to go look in the parts list. Really looks like 688 microfarad at such a specific value. Such a specific value. What the voltage rating on it is. It doesn't really say. I'm going to have to check the schematic before I just throw something in there that's underrated for it. I'm going to throw an electrolytic in temporarily. But anyhow, there was a quick example of looking at tantalums to get an idea if they're shorted or not. We got a couple more here we can look at and get the backlight back on. Hopefully that's showing up. We've got a tantalum here that I don't think will show a short. No. We've got two tantalums up here. There's a red dot on these for polarity that I'm observing. That appears open, as does that. Let's get out of continuity mode. Oh, I always hit one too many. Let's go back and look at these again. Looks like there's definitely a capacitor charging on the backside there someplace. Concerned that this guy is where I'm seeing the 35 ohms at, or the 31 ohms. I think I'm going to go ahead and pull him out and test him out of circuit. It's interesting that it's in that little carrier. Is it labeled positive? It is. It is labeled. So one side definitely came loose. One side not so much. I know I'm working off camera. There we go. So let's take a look at him for resistance. This is going to be a bit tricky to do here. He's so small. If we still see 35 ohms here, we have another bad tantalum. Looks like he's probably okay. Capacitance. .2 microfarad. Without looking at the schematic, I don't know for sure what he should be, but he looks like he's probably okay to me. It says to me we're still going to see the 31 ohms down here, which again may be totally normal. I believe this is the 5 volt side and this is the 24 volt side. So let's see if we can get that second hole opened up, get him put back in. He might actually be important to the circuit. which would kind of be his reason for living. He was in this orientation. Get the solder someplace I can work with it. And let's see if we can get him resoldered in. And he's back in. Now I will go look up what that capacitor actually is, what C41 actually is, and we'll go from there. So the capacitor that was actually in there is a 6.8 microfarad 35 volt tantalum, and I think what I'm seeing in the marking is it's hard to read, but I think it's actually labeled 6R8 microfarad, which would be 6.8 microfarad. For now I'm going to substitute in a 10 microfarad 50 volt electrolytic. It's just a quick substitution at this point, just to give me an idea, if I can get the drive to actually operate. These tantalums should all be replaced at some point, so band lead over here. Like I said, this is a temporary. It's in power supply rail. I don't think it's actually critical component. Electrolytic's going to be close enough for what I'm trying to do here for now. And I guess honestly I could solder this in the back of the board since the board's loose. I'd forgotten the board was loose here. That actually hangs. It's actually not the best positioned replacement cap. Everything here is well silk screened. I'm just going to lay it down like that for now. So negative is going to negative. Like I say, this is temporary for testing. Get it to drop down in there, maybe. Yeah, I don't recommend this is a permanent solution. It's really not, but I will tack this side to hold him in place. We'll flip the board over, solder both leads from the other side, trim the leads, and call that for now a good enough replacement. Negatives to negative, the leads aren't encroaching on anything. I should be able to set him back down in here. Get everything plugged in, screws all in, etc. Yeah, assuming this drive will work in the target system, I will replace all these tantalums. I don't think there's any actual electrolytics on here. I can go back to the parts description, because there's actually more tantalums called out in the parts list than I'm seeing here. At the same time, we don't have the data separator or the select stuff populated on this board, and those schematics cover a fully populated board, so it's possible the extra parts are related to those. There should be two connectors here, P6 to P6, P5 to P5. P4 was unused. He's strapped as drive 1, which he needs to be for the configuration I'm going to test him in. The positively electrolytic is to the positive. These two guys are tacked back in, but not as well as I'd like. I'm going to touch up the solder here on the top of the board. I'll probably clean my tip. I think with that, I can go put him back in the circuit, or back in the computer, and see if I have any chance of him working one of these drives. It's not this one had a broken transistor lead while I was looking at it as well, where the transistor had been smashed. Down it was up here by the head connector. Did I actually look at that tantalum up here? We didn't pull it out. Yeah, I'm measuring K ohms here, so he's not shorted. So, guess with that, I'll put it back in service, and we'll see what we get. Oh, there's another tantalum hiding there. There's 4. 1, 2, 3, and 4. You know, there's 2 places for capacitors there. There's a place there, place there, place there. So it may just well be that the others aren't. All the ones in the parts manual, you know, call it all the extras that I just don't have because I don't have those options installed. So, with that, I'm going to go do this test. Well, we got further than I did the first time. The A drive on the machine actually moved the heads like it was trying to boot. Everything just kind of stopped in the middle. And there's a second tantalum sitting right here that is identical to this one physically, and he started to smoke. He got really hot, really quick. And like I said, started to smoke. So I didn't even see him when I was looking over the board before. So we know this one's bad now. So we got enough power to the board at this point to get enough voltage across this one to cause it to light up. So let's go ahead and pull him out. I think I can fully do this from the top of the board. A little bit of solder down here. Actually, I need to turn the desoldering. I'm probably not going to be able to get the desoldering pencil to clear those out. I don't really want to pull the PC board off again. I may end up just tacking something in here. Let's see if we can get him to release. That's into the ground plane there. I may not get enough heat through the board. Yeah, I can actually see a fracture on the package. He should be the exact same part based on what I saw in the schematic. Yeah, labeled the same. Get over here to resistance, get the backlight on. Hopefully you don't have so much glare you can see that. This glare is an issue here. Let's measure it for resistance. 2.4 ohms. No, 2.4 K ohms. That's interesting. So it must have opened up after it got hot and did its thing. Seriously doubt I'm going to get either one of these to. But that's okay. What I'm going to do is swap in another 10 microfarad electrolytic. 50 volt job to that position. Again, this is just temporary. Kind of lay him down in there. This is very much temporary. Yeah, I wish I'd have had the camera going down there. I'm just not set up to shoot video down where I've got the S100 machine that all this stuff kind of lives. That should be enough to let me tack him in. I've got him the right polarity. That's very much just tacked in there. Negative is back. These are really cheap Chinese capacitors. Not something I would use for any period of time. They're actually labeled 105 degree C caps. I've never heard of HYNCDZ. Well, I will run back off downstairs and plug this back in and see what we get this time. So sorry for shooting this handheld, but there's the floppy drive that we just did the repair on. Replaced the two tantalum caps. You can see my MSI, or my Altair sitting back here. The front panel, I booted into CPM22. And I don't know if you can see it down in there. Maybe you can hear it. But you can see the head slowly stepping up the disk. This is a really good sign. So this drive seems to be back to life with those two tantalum caps out. And the issue I'm chasing here is I'm having trouble on this drive with tracks above the mid-60s. Getting errors when trying to verify format. So the idea was to get a second drive in here just to see. So really pleased. This also says the drive strapping is most likely compatible. It's on track 58, or 51, 52. As you can see, these drives are monsters. They're really huge. Here is a box of 5 1/4 inch floppies for comparison to the drive. So yeah, it's very old school, but very correct for the era of the system I'm trying to rebuild here. So this is a system we've looked at in a bunch of other videos as I've built the hardware over here out in the front panel. Eventually this will all get assembled into a case and it'll be a somewhat... Hey, it's verifying tracks. That's a really good sign. So it formatted all 77 tracks, and now it's formatting or verifying. Oh, it got a bad sector on track 7, sector 2. So that's interesting. Well, anyhow, it's progress. The drive powers up, attempts to do something. So I'll wrap this up here, and we'll talk soon.